When data is written on a disk surface, there are certain recording considerations that must be taken into account. Each block of data written is separated by an inner block gap to allow the device enough time to activate the read-write heads for data transmission once the data or free space has been located on the disk surface. Because of this requirement, each block of data written on the surface results in some unusable space. To reduce the amount of wasted space, the concept of blocking was introduced so that records could be defined together to provide a larger physical block for recording purposes. As a result, the block size indicates the size of the physical block, while the logical record length indicates the size of the records within that block. In effect, records are being bundled into blocks to increase the efficiency of writing them to disk. ZOS references disk drives by using the device geometry of an IBM 3390 disk subsystem. So in extending our previous example, we can see some of the concepts associated with space-related terminology. A track represents the total distance around the disk, while the cylinder represents all the tracks that are directly located above and below each other so that the read-write heads don't have to be repositioned to process the data. These platters were stacked such that there were a total of 15 recording surfaces available without moving the positioning arm. If one were to draw an imaginary line through the tracks, one could see how a cylinder would result, which is what gave rise to the term cylinder in allocating space. So 15 tracks make up one cylinder of allocated space. There are many ways that records can be defined and blocked. Records may be fixed length, or they may be fixed length blocked. Records may also be variable, variable blocked, and variable block spanned. The simplest of these is that the records are defined as being fixed length. In this case, the file is unblocked so that each record is the same size as the block. This method is discouraged because it results in a large amount of wasted space. For example, if each record results in an inner block gap, then a record length of 80 bytes would only allow 78 records to be stored on a track, which wastes over 49,000 bytes of disk storage. If we define these same 80-byte records as fixed block, then we could define a block size of 27,920, which would hold 349 records. Since two such blocks could be written on a track, we would now be able to hold 698 records on a track and waste only 824 bytes. Fortunately, we no longer have to manually calculate the optimum blocking, since the system provides that capability automatically when it is requested. Variable records are also unblocked, as our fixed record length example, but each record can be a different size. Each record has a small prefix which indicates the size of the record. The prefix contains a block descriptor word and a record descriptor word which provides the length information about the record. Variable blocked records allow us to block these records together, but they contain the same descriptor records to provide length information. The only difference is that a variable blocked file will have more than one record in a block. The block descriptor and record descriptors are each 4 bytes in length. Variable block spanned records are a special case, where the size of the record might be prohibitive in terms of blocking. So this provides the ability for the records to span blocks by identifying a beginning, middle, and ending segment. In this case, the record descriptor word also contains information to identify the segment.